Hi, I want to say welcome to everybody. This is my first talk. I did some research for my uni dissertation and I just thought it'd be kind of interesting to show to people. So basically, a little about myself. I don't have a who am I/all screen because that's going to be cliche Windows nerd. I have some certs like OSCP, CRT. I'm not going to list them because it's useless. I got first in a cybersecurity and digital forensics degree. If you're going to go to uni, I don't know, the demographic isn't really for that, but do computer science, don't do cybersecurity. So my motivations for this talk is I implemented an interesting technique and just thought it'd be useful. So it's basically about taking a return instruction pointer, basically feeding it to an intrinsic and getting a function name and a module name and a function name without using debug symbols. So basically, so this is the content I'm going to be covering. So first thing is stripping CRT and Win32, basically tiny binaries. You can early load a DLL into a process. So loader translations, very useful to know as well. Call a module name, exception handler record, information gathering. I'm not going to read out the rest, you can use your eyes. Okay, so this talk is kind of intended for newbies. If you know anything about Windows internals, you'll see the content isn't too difficult. I'm also by no means an expert. I'm a noob. I've only got like about a year and a bit of Windows research, C programming, that kind of stuff. So basically, the content of my uni dissertation is tiny, but the stuff you kind of want to be interested in that I found interesting is project management and literature view isn't too fun. So basically, what ended up happening is I just took some Sector 7 courses to learn C and some hooking theory, basically using like detours, other hooking libraries like minhook, basically EDR bypassing, direct mass and like assembly syscalls. Learned a great deal about process and memory-based Windows internals. Very useful things to know. So basically, my biggest problem that I came across was I could hook basically memory management, process management functions, but I didn't really know why certain hooks were being hit, and I couldn't actually translate it into a way that humans would understand. So as it says here, human-friendly. Some very useful information. CRT and Win32, or the universal CRT runtime. Basically, CRT handles like exception handling, like useful debugging information. Like if you screw up, you basically get handheld the way through. Win32, if you know anything, is basically like hardware from a high-level perspective. You can basically interact with memory, interact with processes, etc. As it says, TLDR. Basically, you can screw up gracefully, basically fuck up, and you get handheld the way through. And Win32, instead of like calling NT-API stuff, which isn't necessarily portable, different across different operating systems, you get that abstraction layer. So basically, I'm talk about cleaning dependencies first. So take this example. It's like a less boring Hello World example. You wouldn't expect much to be going on in the background. A simple PE, that's not the case. A lot of CRT, a lot of like runtime stuff. As you can see, dependencies from can't remember his name because I'm nervous, but it is what it is. So you see here, like the range of functions that are being used. So we need things that actually depend on. So the CRT, if you don't have CRT stuff, you come into issues. So as you know, if you don't have anything set up, you fail. Yeah. Basically, you can take this a step further and you can strip CRT and Win32, use a custom entry point, and I use process hacker NT internal headers because they're beautiful and some very smart people worked on them. So these are the steps to remove it from a Visual Studio project. So basically get rid of runtime checks, SDL checks, basically just force a private lib from NTDL, and displaying progress messages is useful too. Cool. So as you see here, I only depend on DBG print, which is nice. I don't have to have anything loaded before me. I can like KAPC inject the DLL into a process and we're Gucci. You see here from an analyst perspective, barely any functions in our stripped binary, loads of CRT related functions here on the left. So now I'm going to talk about loader translation and contracts. So you see here, this is like a typical diagram you'll see. I'm going to get out of the way of the projector. A typical diagram you'll see which actually completely abstracts the loader translations. The loader translations are ways of staying portable across different versions of Windows, and the basic simple virtual actually imports from a umbrella library or a contract library, and that forwards to kernel 32, and then kernel 32 will call kernel base, and I had to write like a little tool based on someone's research, which I can't remember the name. So you see here, it was Lucas G, that was it. These are some really useful resources, and the API set map C++ from Zodiacom, which is someone, once again, nerves, but it is what it is. So you see here, I came across these two projects. Dennis Babkin, very, very smart man. He wrote a project which is like kind of aimed towards game cheating, where you can create a driver, an unsigned driver, and as I said before, KAPC, load a DLL into a process, which steals a service security descriptor from a known DLL, and basically allows you to bypass like things like SIG, Code Integrity Guard, and processes like Edge, which is cool, really, really interesting. So I'm going to talk about hooking now. So basically with hooking, I was able to like intercept and tamper with like most memory management function calls on Windows, like process creation as well, and this is process introspection, which introspection isn't a real word, but yeah. Detours was the library I chose, but as you can see here with a graph of what actually is involved, it uses Win32. So as we've seen before, we remove Win32 from the process, and as you see, it's a slight problem for us. People shit on detours, which I don't really see an issue with detours. Like they say with threads you have problems, but I didn't have any problems because I was like tampering with simple malware. Minhook was another option, but getting Minhook working in 2022 is just a bit of a pain in the arse. It's like a 2006, 2008 project, and I didn't have the time to screw around with that. So also WBenny has another project called Detours NT, and everybody says don't be a paster, but if it can save you time, you can get the job done, and you understand what it does. I don't see an issue with it. Like, as you can see here with the tool by Lucas G, now I can remember his name, you only depend on NTDL, which is beautiful. It does exactly the job you want. It brings back to the KAPC point. So hooking like an NT-API function is really, really simple. So you just basically get yourself a type def, basically have a function prototype, which is provided by PHNT headers, get a copy of the original pointer, and then basically you can tamper with anything that gets passed. You can print out parameters. You can basically have extra functionality within a hook. So this is the point where I was talking before. I didn't know how to translate into a human readable or human understandable thing. I just had things hooked. I could do things in place of a process, in place of a process function call, So we could use assembly to like walk the PEB and then basically just get a pass PE and then get your function pointers. That's one way of getting a Win32 function pointer from an NTDL dependent DLL. But I found a different way. So you can use loader get procedure address, which gives you a nice set of information such as like module handles and this is an NTDL equivalent of load library get proc address. So you get load DOL and loader get procedure address, and it does the job nicely. Depends on NTDL again. So this is where I was really confused. I was getting 2 or 3 extra function calls from a hook process, which I didn't really understand, and I wanted to know why. And so I took a bit of a detour, pardon the awful pun. So this would allow me to get meaningful information. So memory addresses of a hook that aren't useful to humans changed into a meaningful human readable string, such as for a dumb human like myself. So this provided the process introspection. Visual Studio used the debug information from PEs if you provided it, but had a hard time translating breakpoint and hovering over a memory address within a hook, which is, I wanted to understand why that was actually, how I could do that if I wanted to carry it out without debug information. So I'm going to talk about call and module name acquisition. So basically, you can use the pad, walk the in-memory order module list, and basically you get nice human-readable information about a module, such as, say, kernel base, kernel 32, etc. And this consists of pointers to nice structures, which have a lot of information, which are friendly for me. This is really tiny for me. So this allows us to keep track of modules loaded in memory in order, kind of basic stuff if you know anything about Windows programming. So you see here, these are the structures associated with it. So the main important things are the DLL base, the full DLL name, and the entry point. 3 things that are really, really useful for me in this project. As you see here, this is a WinDBG output, which contains a human-readable list. It doesn't actually go into the substructures within it, but it's useful for a demonstration purpose. So now I'm going to talk about exception handler record information gathering. So basically, this allows us to get a pointer. Before that, I'm going to talk about a return address compiler intrinsic. So this allows us to basically find the RIP into a function that called a function. So in this case, if I had this inside a hook, I'd be able to point to whatever called the hook. So say memory managers or a loader function called it, I'd be able to understand why that hook got hit. So from this, I'm able to step into exception handler information gathering. So the P-data structure, which was actually documented recently by Modex. He did a really cool post about getting SSNs, basically syscall numbers from these structures. It contains like a wealth of information. It's stored in the P-data section of a PE. These are registered for functions that basically allocate stack base or call another function, aka non-leaf functions. So not the end of a chain. So MDSec and Modex has the post out. I'll put a link right at the end. So to get these actual exception handler records, you can use RTL lookup function entry, which returns you runtime functions. As you see, you get a control PC image base. Really, really useful things. From here, we're able to get like the begin address of a function, which allows you to call a Win32 function without having to go through all this extra jumping through hoops. As you see here, this is IntelliSense basically hand holding. So I was able to see from like NT allocate virtual memory. This was actually called by virtual lock. So I'd be able to watch the call hierarchy all the way from Win32 all the way to NTDL. As you know, this is user mode hooking. So if you use direct syscalls or unhooking, you'd basically be able to bypass this hooking logic. But I didn't really care, just for learning. There's one caveat with this. There are certain things that aren't actually exported, as you know, by a PE, so private functions such as RTLP functions or loader P functions. One step further, if your actual target doesn't have any exported functions, you can't get this like main called this hook, basically. So that would be in the case of like virtual protect, and then you wouldn't be able to jump up to whatever called virtual protect. So to implement the full technique, what you can do is now we have all of these steps. All of these steps completed. We can clean our DOL from dependencies. Basically, as I said before, you can turn into PIC or turn into KPC ready DOL. We can obtain the module name and module and function name are now ticked off the list, and we can trace all the way down to the kernel. So implementation, horrible to look at, but it is what it is. Don't judge more unsafe code. This is just learning code. As you know, C in Maxploit's talk, like even the experts can't implement C and C++ perfectly. What would someone with like 6 to 9 months of C programming be able to do? As you can see here, we can step through logically. It takes a PC value, which is program count value, or RIP basically, which is provided by the intrinsic mentioned earlier. You can step through, get a runtime function for it. If you get a runtime function, you can search an address within a module. That will allow us to get the pointer to the module, which you can PE pass. Basically, PE passing is like day one stuff you learn. From that, you can step through the exports and compare if that address is within an exported function. Therefore, from that, you can actually get the function name, which is useful, really, really fun. So now's a quick demo. Let's hope the demo gods are on my side. Please be on my side. I'm sick. Oh, this is really annoying because I've got a 4K laptop. Everything is like really, really blown up. I don't know how this is going to look. As you can see, look how giant that bar is at the top. So we'll go with the non-clean binary. So this would be a PE which calls something. It's going to be horrible to look at, but it is what it is. You can see here. Why have I got no debug screen? You see here, our process gets attached. We've got no errors, and NT-allocate virtual memory is called. We can see the DOL that actually called the function. So instead of kernel 32, if it was explicitly linked with it, we're actually using kernel base because we haven't linked anything. And we see virtual lock actually called hook NT allocate virtual memory. Virtual lock hasn't been hooked in this case. So we can see the logical jump, and we can get the return address, which points towards the code. So if I were to clean the binary up, just control it. So you see the return address from NT-allocate virtual memory, we've got no errors, and yeah, we can see our print demo clean exe actually called the function, because this was just using the function in itself from PHNT headers. Cool. Go back to the slides. Alright, cool. These are okay. That's a little shill for Secret Club, by the way. That wasn't intentional. These are the references I used. Some very, very smart people in here. As I said, Secret Club. We've got Namazo, Matiwati, Jonas, Luke, and Dax. They were very, very helpful in this project. Special mention to Dennis Babkin and Rob BMM. We've got Dad 98 as well, up and coming. He's got a talk in SteelCon, which would be really, really useful, really, really good. And basically. So if I were to do another CFP, I've been trying to weaponize the driver LPE, and I've been writing a hobby stake on implant in situ. So I might do a talk about that and get a bit more experience. Yeah, cool. Alright, awesome. Yeah. Oh, so warm today, Jesus. Awesome. Yeah, we still got 10 minutes left of this talk. I don't know what you guys want to do, but yeah, that's a speedy. That's
so I was wondering if you could maybe explain what some of the stuff that you stripped out does. So what changes when you write code at the level where you stripped out these things? Because Windows is sometimes bloated.
Yeah.
You can't be doing that.
Yeah, so if you have a PE and you strip CRT and Win32, you basically get none of the hand holding. If you strip out Win32, you basically have to use direct. You can either, as I said before, get the Win32 function pointers, build yourself a type def and call it that way, or just be the same person, just use NTDOR exports, which should be done. Yeah, that's basically one of the issues. So this was, if I had a target, like a piece of malware that I injected this DOL into, the DOL that's being injected is tiny. My target doesn't have symbols because it's a piece of malware. So this way, I wouldn't actually have to use like a PDB that's packed with it. I may have references to PDB, but it won't be available. Did that answer the question?
Yeah.
Cool. I don't know if there's any more. That's a very speedy talk. Cool. Thank you very much for watching.